Hello and welcome back to the Astroimaging channel. Tonight's session is just going to be open session on processing, a continuation of some data that I had posted previously and never got around to processing because it was kind of a hectic month. I do want to thank Tolga, Gaston, and basically everyone who stepped up and kind of helped to present. As always, before I jump into my session, I'm hearing an echo of myself. I'm going to start. Let me see. Guys, if you're in the room, just make sure your mics are muted. There we go. The echoes go on. Perfect. Sorry about that. I do want to show off this week's image of the week. Can I find the screen? This week's image of the week goes to Matt Herbeck. ARP273, really cool interacting galaxies image. Check it out on our website, theastroimagingchannel.com. Of course, that is the same place you go to submit by clicking there. Or if you do want to take part in this conversation, you can watch me right here, but you can click that and get it in our chat. You can detach it, pop it off here, and then watch the video and put this chat wherever you want, or whatever, I don't know, whatever you want to do with it. Other cool thing is if you're watching us on Apple TV or something like that, you can pull this particular chat up right on your iPhone. So, or whatever device you're using is. Okay. That is done. Oh, don't want to close that just in case. That was an important window. Gotta pop back here. I know that Alex wanted to say something before we jumped into the session. So, Alex, are you there?
Yeah, I'm here. I've got to turn everything back on again and then get back over to my email here from Warren. Warren Keller and Ron Bretcher put on a workshop down in Texas, and they're going to be putting it on in Texas. They put it all already on in Arizona and in Orange County and someplace else I forgot. And they're looking at some other places, taking their travel and show. I managed to catch the one in Orange County and found it really quite productive. It is expensive. It's $650, although they are giving a discount right now if you register now. If you're any place in the area, or if you're going to travel, you're going to travel. Go on down there. It's 18 hours, 3 days, and the classes aren't that many people, so you actually get to work with Ron and Warren. I really suggest that you look into it. You go to IP for AP and you'll find the link and everything else there. I don't want to turn this into a big advertisement, but I really got a lot out of the show, and I think that it's worth telling you guys about. So there. Thanks, Adam.
No problem. Thank you, Alex. Yeah, definitely. Warren knows his stuff about PixInsight, and I do not suggest buying PixInsight without at least buying Warren's book, which is basically the documentation. Let me see. I always hate showing you guys that right there, that infinite window, but I got rid of it quick, didn't I? So this is the data that I had shared. Oh my goodness, and I wanted to get a link of this. I was having trouble clicking this particular window. Well, either way, I will get this posted in the description of the video because some things changed before I was doing this session. But yeah, so this particular data is from NGC 4565, Edge on Spiral Galaxy. I am trying to think right now what I'm going to do, because what I really wanted to do was do deconvolution on this image. And I had a chance to do a quick rerun on it, and I came up with another issue that I wasn't really expecting. Let me show off what that issue is. Because I just did this, it's going to go quick. Look at that gradient in there. Very sharp gradient. I think it's just in one channel, but I don't quite know what caused that. Or I shouldn't say it's just in one channel, but it's stronger in, yeah, the green channel right there, which is, of course, why it's green. So that really has to be taken care of. What I'm not sure of, in fact, let me check this out. I am, obviously, this is an open session on processing, so I'm just talking through this. I'm trying to give you my thoughts as I go. So there's a couple of things that I know I have to do. I'm most likely going to do a dynamic background extraction. When I processed this earlier, somebody said, I usually use automatic background extraction. Let me see what ABE does as opposed to DBE. ABE obviously gives me slightly less control over generating that background mask, but sometimes ABE does a good enough job that you just don't need that time wasted generating the background mask or generating the samples to generate the mask. So I did a quick ABE. I'm going to put a quick temporary stretch on it. Got rid of a lot of it. Didn't get rid of all of it. Let me show you here. Got rid of a lot of that, but there's still kind of a line going through it. This is one of those things where a second iteration of it might be appropriate, but let me, that tells me it's done by ABE. Let me take DBE. I'll get to show you a quick comparison. Because of this bright spot up here, I like to cluster a bunch of samples up there. A lot of times it'll help get rid of it without much concern. It just kind of does it, but I find it helps to cluster them up there. For this, I just throw a bunch of samples, try not to hit any stars. Don't need this many samples for a gradient like this. It's not a very complex gradient. Of course, there's never really a problem with having too many samples. You just want to make sure that when you do this, correction, I'm going to start with none, because when I do this, I want to see that gradient that's in the image here, because I'm going to subtract this image from this image, and I can already see that I can be a little bit more detail. I need a little bit more detail out of it. Oh, right there, perfect, perfect. Let me show you. So I increased the tolerance by a bit, and what that does is gives me a lot more. It's hard for me to show you a comparison of these. Gives me a lot more detail, tighter detail. You can see more of the gradation in brightnesses here, whereas right here there isn't as much gradation, but it much more accurately represents that bright spot up top, and I think that line that seems to go through the center there. So I prefer this background model to that first background model. And of course, that background model is generated here. So all I need to do is change that to subtraction, because I want to subtract the light pollution. Pretty sure that's light pollution. If I thought it was caused by improper flat fielding, I'd be more inclined to use division. But since I believe it's light pollution, I use subtraction. Going to apply that. Wait for it to finish. Got my finished image here. Yeah, that took care of it really well. Oops. My ABE image, you can see, I think, even without me resizing it, you can see the bright spot up here basically gone in the DBE. This kind of line right here, it's still there, but it's so light in just the green channel, I could get rid of it with one more iteration of DBE, or I could just wait, and I think towards the end I'll probably have a better shot of getting rid of it. But I'm kind of happy with that. Let me see here. I'm going to pop back over to the chat and just see if I came up with anything. Have I tried linear fit, the red, green, and blue, and then recombine the channels? Mitch, yeah, so I can run linear fit on RGB, but basically what I do with every image is I do color calibration, and it's kind of doing the same thing. It's a little bit redundant. I would be more inclined to use linear fit for narrowband images where the color calibration isn't really relevant. I might use it in RGB images if the channels are very far off, or for example, if I am doing well, here we go. I'm about to do this next step, so I'm actually going to get rid of that. I'm done with DBE. That's a dynamic process. I need to get rid of that. Channel combination. Let me think. Get rid of that. Yeah, my ABE. Yeah, that does look a lot worse than the DBE. So Alexis, you and I were discussing this before the show. You saw right there the differences between the two. I want to do one thing first. I want to use channel extraction. Where are you? Channel extraction. Channel extraction right here. I am going to change it to lab mode, disable those, and do that because I wanted to pull a copy of just the L channel out, safekeeping, put it up there. Oh, I do want to look at that. I don't notice much of that gradient in the L channel. I think the gradient is more in the color. So that kind of tells me something. What does it tell me? Well, it tells me that first I want to do color calibration on this. I am going to do it the old-fashioned way. I'm not going to use photometric color calibration because honestly, it would take me a long time to find the original data on my computer. And I don't want to spend all that time looking for it. So I'm just going to do the background neutralization, color calibration routine, background neutralization, find some background sky, no stars. Right about there, preview 1. Image 11 DBE, preview 1. Image 11 DBE, preview 1. Got it. Applied. Come up here. White reference. It's a galaxy image. So I can select the galaxy. Make sure structure detection is unselected. Use this preview for the white reference. That's preview 2 in this image. Preview 1 is my background reference. Structure detection. The reason I leave that unchecked is because I'm using a galaxy as my white reference. If I wasn't using the galaxy as my white reference, then I would just use the whole image and use structure detection. This is going to go through, detect all the stars, average the color, and then distribute along that color palette, so to speak. But since a galaxy is made up of millions and millions of stars, I might as well sample from millions of stars as opposed to, I don't know, maybe 100 or 200. So there we go. That's my rationale for doing it this way. Let's get that in there, apply it to that. I do need the screen transfer function tool now. I can check link channels and apply it. And this basically shows me what the color palette is going to look like when I do stretch it. I am not crazy about that color. Wow, okay, so that's kind of funny. Why am I not crazy about this? Seems to be coming across a little bit green. And if that's the only reason, then I'm not so concerned, because I can use SCNR to remove a lot of the green. I'm going to run this without a mask of any sort and just see what happens. Shouldn't be any green up in space. Of course, the background is a blending of RGB, but there shouldn't be any green in any deep space objects, with the exception of a planetary nebula, of course. But so you're safe to use this tool to remove a lot of the green. I just want to do that as a test. I'm not going to keep that, but I can see that does imply to me that a lot of my issue is just with the noise in the green channel. So I'm not going to worry about that. I am going to... It's funny because I did this before the show, and I liked the way this turned out. Time is it? I have enough time. I'm going to take that color calibration back. Preview 2. I'm going to try... What's going on here? Okay. Let's try structure detection. See what happens. Keep it linked. Wow, yeah, it's the reverse this time around. Now I prefer the way that structure detection did it. Oh well, you never know. Try both, because one could be better than the other, and you just always pick whatever looks better and go with it. So now that I'm happy with that, I'm going to get rid of these. I had pulled my L channel out because I am tempted to use deconvolution on it, but I don't know if I have time. I am going to try and keep it simple and not do that at the moment. What I'm going to do is I am going to jump right into the stretch. And obviously use histogram transformation in the preview to stretch it. If you have really bright stars in your image, you can start with a mass stretch, and that'll help keep those stars tamed and from blowing out. If you're not concerned with any bright stars or anything, then this is just kind of a quick way to go about it. Just basically iterative back and forth. You are darkening the background in this step. You are stretching in this step. Of course, the background lightens up a bit. I can get rid of this preview. I could see what my image is looking like. Obviously, I want the background darker than that. I want the foreground a bit lighter than that. Getting close, though. Right about there, I'm getting close. I think I just want to finish by darkening the background. I know I'm going to be clipping some stuff here. So what I'm going to do is I'm going to do my last step with curves. So because histogram will clip. Oh my goodness, my alphabet. Not so good today. Curves transformation. Ooh, that's a nice S curve right there. I bet that's going to work out on this image. Let's see. Looks perfect for this image. To do perfect. So a couple issues remaining. I see some chromatic noise, which is actually a little bit of noise in the luminous channel as well. In my estimation, it's a little blot because you use a little color. But I don't want to saturate until I get rid of as much of that chromatic noise as possible because I will be saturating the noise and then I'll be trying to get rid of it and I'll get big blobby ugly things. So what I want to do is I want to use a tool that I'm comfortable with, and I have been going back to this ACDNR tool because it's just kind of a quick way to generate first your mask. So what I'm going to do first is I'm going to work on the chrominance noise first. So I like my background to be almost white in my mask, like that. I can have it be somewhat sharp. Not really concerned about that. Get rid of that preview because that looks like a good mask to me. I am going to not apply that. I'm going to apply the chrominance. It's going to use that lightness mask. I can see from here already. Wow, okay, so I'm going to try and give you a good view of what's going on. Oops, that's going to be too good of a view. Right here. Hopefully you can see that. There you go. So all that color just disappeared, right? What did I just do? I'm forgetting my shortcut here. And what did I do? Yeah, so you can see all of that chromatic noise in there. As soon as I apply it, just goes to black and white. And even leaves, there's a little bit of salt and pepper, lightness noise in there, but I don't know, it's pretty random looking. It leaves it looking pretty nice. I do want to go over to my Galaxy, see what's happening to that when this gets applied. Make sure it's not killing the noise in my Galaxy. But basically what it's going to show me is how well that mask is protecting. And that mask is protecting nicely. So I do believe that I can just apply the chrominance noise reduction right on this image. Should be pretty good. We will see. It's going to take a little bit of time. Here we go. So, before and after. We're looking at the background down here. Before and after. All that chrominance noise is gone. So let's look at the lightness noise at this scale. There is some lightness noise to get rid of. If I preview this, Any noise in my mask is going to leave a little bit of noise in the image, and that could be a good thing, because if it gets too smooth, it can look fake. So I'm actually going to leave my mask how it is, with that and a little bit of noise in there. Going to take the amount of this down, and I am going to try and get rid of that preview so that I can make a new preview down here. And I just want to see what's going to happen. Took a little, made it a little fluffy. Yep. Forget all my shortcuts. And makes me jump around. And it puts the chromatic noise back in there. That's already applied. That's too much. Just trying to get rid of a little bit of the noise in here, and I think that actually at that 0.50 is in the right spot. Close enough. Kind of blurred it a little bit. I don't know. I'd probably tweak that. I actually probably wouldn't use ACDNR for my lightness noise reduction. I might use TGVD noise or something like that, but I'm trying to do this kind of a simple way. I don't know if he's still in the room, but Alexis was looking for just kind of a baseline. What do you always do on every image? And basically, it's pretty easy to process an image. Alex had done PixInsight, a loaf of bread, a jug of milk, and PixInsight, just kind of those basic few steps. And PixInsight can be a lot more simple than we give it credit for. But because there's this whole toolbox of crazy different tools, you know, and I would say 95% of PixInsight users only use about 10% of the tools. And there's, I don't know, I could probably find 20, maybe 30 tools in here that I've never even clicked before. So it's basically a matter of learning a few of them, learning the routine first, then expanding on that. Did someone say something? Maybe not.
Adam, do you still have your linear image up there?
My linear luminance image? I have my linear luminance, I believe. I don't have...
Your linear RGB?
I don't, but I can create it really quickly.
You want to try something a little different to bring out a little more star color?
Sure. Let me first get this one finished, because it does look like we have a little bit of time. I'm just throwing that curve back on this image to darken it a bit, because in my final step of the basically simple way to process would be, oh my goodness, my alphabet is gone today, color saturation, not saturation. Color saturation. And then let's do this, take a quick mask off of it, do that. Oh, wait, let's see here. Yeah, there we go. And there we go. Get that applied. I like the look of doing another iteration. And then we're pretty good. I'm pretty happy with that. I might go back and do a DBE on it because I see a slight gradient has worked into it. But otherwise, I'm pretty happy with that. But let's jump into the rabbit hole. Let me think. Is that my? Let me think. When did I create that clone? I just created that clone, so that's not linear. No. Image 11. This is my linear before DBE. I think that my DBE tool. Oh, I need all new samples. Okay. I'm just getting that image ready, Eric. I should have it shortly.
Okay.
Just going through that same process.
This may not be exactly what you're looking for, but I think you might find parts of this interesting.
All right. I think that's close enough. Do you want color balance, color calibration, background neutralization?
Yeah, why don't you do that? I think that makes sense.
Oh, this is going to get confusing. DBE1, preview 1. Okay, DBE1, preview 1. Okay, there we go.
All right, turn off your preview.
Oh, off screen transfer function?
Yeah.
Yeah.
Bring up the arc sign stretch. Okay, hit the preview button. Hit the estimate
Yep.
black point. No, estimate black point.
Yep, got it.
Oh, crank the stretch over to 1,000. Hit it again. Now move that slider to the left, the bottom slider, until all the little speckles disappear. And that's your stretch point. So turn off the preview and then drag the caret over. No, just close the preview, Adam.
Oh, just close that?
Yeah.
Okay, got it. Yeah.
I think you get a little more color. See, you got some blue stars. You got some green stuff in there as well, but
I wonder.
it's a little, I think, more adaptable stretch than the mass stretch. And
Yeah, I mean, for color, I blur the heck out of this. It's got great color in it. I blur the heck out of this to get rid of some of the noise.
Or you could do that, or you can use this as a background and put your luminance over it.
Right.
But I think your stars would be a little tighter and they get more color. I don't know if that's coming across on my screen, but I think if you compare it, you'll see you get a little more color. I'm not sure that does it for you. I think that I would not blur it and just go through TGB denoise and get rid of the green and then use that as a background. Because when you blur those stars, I think you're going to lose color.
What am I looking for? CNR. Hmm. And this is what you do when you're processing an image. You tweak it, you look and see what you like about it, what you don't like about it, and you might want to change some little thing. I look at that image and I say I should bring down some of the low-end red and see what happens. Looks more natural there. Now I have this that I hadn't really done much with. See if I can get a quick process on this. Let me think. What do I have to do here? I think I might be pushing my stars a bit. We'll see what happens. But see if it falls into place. $11 dB. Yeah. Okay. Not bad. Much better color throughout the image, throughout the stars, probably throughout the galaxy. Let me see here. Where did my last image go? Did I lose it? Here we go. That's it. That's all I really want do is show a comparison of the two. You can see color over here seems to be a little bit better at the arc sign stretch. Let's get them the same size at least. I forgot all of my shortcuts, so excuse my stumbling around with all these windows. But you can see, yeah, much better color. Gold, more gold. Let's find a blue star. Nice bluer color. Much bluer stars down here. So that's basically my walkthrough of some processing. I am going to jump back over, see if I missed any comments. First, trying to take back my screen. Any comments while I'm reading? Any comments in the room while I'm reading through? Quick question about the latest Pixel Insight. How to drag and draw to create a preview? Drag and draw. Shortcut Alt-N. That's the way I do it. Yep.
We got some screenshots up there showing how to add that toolbar back after you reinstall Pixel Insight.
Cool, cool. All right, so I actually don't see many comments. I hope you guys all appreciated my walkthrough of the processing.
There was one question on there about why you didn't denoise before stretching that I saw.
Okay, so you can do it either way. If you are denoising before stretching while still linear, you have to be a lot more careful and a lot more gentle because a little bit goes a long way. And it's hard to tell early in the process if you're doing damage to your image. You really don't know until further on in the process whether you've kind of done some sort of destructive technique. So when I do pre-linear or linear noise reduction, it's probably just a slight tweak to the background with a mask on it. Just a very, very slight tweak to give me like the littlest edge on that background noise. It's almost, I'd almost say I don't suggest doing noise reduction early on because it really should be one of your last steps. You know, there's signal buried in that noise, and noise reduction is destructive. Noise reduction actually destroys legit signal. We use masks to prevent that from happening, but you're not going to get it perfect. The later on you do it in the process, the less impact that destruction is going to have. So unless you really know why you want to use noise reduction early on in the process, I say don't. If it's your second walkthrough of an image and you say, my problem was that grainy background just killed it, then yeah, you have a reason to consider using it. But if you don't have a reason to use it, work that out of your flow, work that out of your workflow and do your noise reduction later on. Yeah, Mitch is saying do a post, ACDNR, TGV denoise, or MMT is probably, I believe, the newest tool, multi-scale medium transform, which is really powerful. You just have to learn it because you can do a lot of damage just the same with it. You use masks and go after the chromatic and luminance noise separately, and you'll have a good shot. So yeah, this week, like I was saying, was just kind of getting back into the swing of things, some processing without script or anything like that. Next week we will see processing of a comment, and it looks like the week after that, David is going to be presenting on, help me out here, David. What was it you were presenting on?
Yeah, pixel math.
Pixel math. A lot of different things you can do in pixel math. So,
Adam, before we wind up, are you getting close to winding up here?
yes.
It looks like Ray and who was it? Ray and Ryan were having a discussion about PhD and SGP, and there was a little bit of I may be completely misreading this. It was back at about the 1809, if you're following the comments, and the question was, how often do you need to dither and stuff like that. How often you need to dither depends a lot on a whole lot of things. For instance, right now my camera in the backyard is out taking half-hour exposures. Well, if they're taking half-hour exposures, I'm going to dither every frame. But who was it, Ray or Ryan said, hey, I'm taking 10-second exposures. Well, if you're taking 10-second exposures, you're taking lots and lots and lots of exposures. One has to ask, just dithering takes some time. It takes 5 to 15 seconds for the mount to move and then get back to where it belongs. So you're going to have to make that decision. If you're taking exposures of 10 seconds, you're probably taking hundreds of them. And you probably don't need to dither every single time, because if it takes you 5 to 8 seconds to 15 seconds, you're using up more time dithering than you are actually taking the pictures. So I, on the other hand, like I said, I'm doing narrow bands back there for half an hour each. My 10, 15 seconds of dithering, it's nothing. It's absolutely, I could refocus each time, and take that minute and a half to refocus each time and still wouldn't be losing that much of my imaging time. Okay, but the other thing that I noticed was that somebody says that they try to settle it back down to within half a pixel. That's okay. I have found, though, that you check to see what you're seeing is. There's no use trying to settle it less than you're seeing. And for those of us whose seeing is less than half a pixel, hey, congratulations, that's pretty good. If your seeing is less than half a pixel. So if you're waiting for SGP to settle to less than half a pixel, that's yeah, wow, that's pretty interesting. What can I say? The other thing is there seems to be a confusion. I forget who it was, Ray or Ryan asked. So how do you get it to settle to 1 pixel? We're talking about two different things here. Dithering, somebody said they dither to 12 pixels each time. And the other one says, well, gee, I try to get it to settle to half. How much you dither and where it settles at are two different issues. It's not the same thing. And I'm not sure that there was a confusion between those two things as if they were the same thing. I can tell it to move 12 pixels between exposures, and it moves the 12 pixels, or what I do is I tell it to high dither, which is so many pixels. But then once it gets there, it has to get to that position and then wait till it settles to within 2 pixels or something like that. So it's moved 12, and that's one set of settings, but it settles to within 2, or as whoever Ryan or Ray was saying, it settles to within 1 or 2. Now, if I've completely mixed that up, Ray and Ryan, well, sorry about that. I was just reading through here, and that's some of the things I noticed. Okay, thanks.
Thank you, Alex. Elmiko, yeah, noise reduction best optimally while nonlinear. Doing it linear, potentially destructive. Doing it before deconvolution, definitely destructive. So just something to keep in mind. Use it sparingly, as you always do with noise reduction, but particularly early in the process. So yeah, we covered that. Check us out next week. In the meantime, keep imaging. Submit your images to theastroimagingchannel.com. We'll review them, and maybe you'll win an image of the week. That's basically all I've got for tonight, guys. So thanks for watching. Hope you all had a great holiday season. Now we hope to get back to having weekly sessions, or at least as many scheduled sessions as we possibly can. But thanks, you guys. Good night.